questions 11 through 20 on the 2012 grade 12 AMC 12B. In the equation below, a and b are consecutive positive integers, and a, b, and a plus b represent bases. 132 to the base a plus 43 to the base b is equal to 69 to the base a plus b. What is a plus b? So, very quick little primer about bases. For example, when we write numbers like 425, we don't write 425 base 10 because that's just implied. But what that really means is that it's 4 times 10 to the power of 2 plus 2 times 10 to the power of 1 plus 5 times 10 to the power of 0. And this, of course, is 400 plus 20 plus 5. And that's our number system. But what if I said 425 to the base 3? What is this equal to? Well, it would be 4 times 3 to the power of 2 plus 2 times 3 to the power of 1 plus 5 times 3 to the power of 0. So this is 4 times 9, which is 36, plus 2 times 3, which is 6, plus 5 times 1, which is 5. So this is 36 plus 11, which is 47. So as you can see, 47 is a lot different than 425. So that's a very quick primer about bases. So we have to do the exact same thing here. But they gave us a little bit of a clue that a and b are consecutive positive integers. So that means, for example, you have a, and then you have a plus 1, and this is what is b. So what this boils down to really is 132 base a plus 43 base b, but b is a plus 1. And that is equal to 69 a plus b. A plus b would be a plus 1, which is 2a plus 1. So that is what we have to use. So using the same system I did over here, I'll do this. So it's 1 times a squared plus 3a plus 2 plus 4 times a plus 1 to the power of 1 plus just 3. Because remember, the last one would be to the power of 0, and we don't really need to write that out because anything to the power of 0 is just 1. And then on this side, it will be 6 times 2a plus 1 to the power of 1 plus 9 times 2a plus 1 to the power of 0, but you don't need to write all that out. So hopefully, if I did my algebra correctly, this should be giving us an integer solution for a. So let's see here, we got a squared plus 3a plus 2 plus 4a plus 4 plus 3 is equal to 12a plus 6 plus 9. So collecting like terms, 7 minus 12 minus 5a, and then 2, 4, 6, 9, 9 minus 6. And this factors, I believe. So we got a 6 and 1. I believe that would work. And then it'll be negative and plus. So a is either 6 or negative 1. But they tell us in the question that's positive, so a has to be 6. If a is 6, b is a plus 1, which is 7. And therefore, the required is a plus b, which is, of course, 13. So number 11, the answer is C. How many sequences of zeros and or ones of length 20 have all the zeros consecutive or all the ones consecutive or both? All right, well, I'm going to start with a few cases here. The first is if you have all zeros. So that basically means there's 20 zeros, 20 of them. So there's one case there. The other one is all ones. And that's, of course, 1, 1, all the way, 20 of those guys. So right off the bat, you got two cases. But obviously, there's quite a few more. All right, so now let's take it one step further and look at the ones where you have a combination of zeros and ones. So you have zeros and ones. But initially, I'm just going to look at where you have just one place. So for example, let's say you have 1 zeros and 19 ones, because the total has to be 20. 1 0 and then 19 ones. And what I'm doing is just putting them in one place, and that is at the very end, like that. So for each of these, as you can see, there's 2. Very similarly, if I have 2 zeros and 18 ones, and I put just them in the ends, so that's the place I'm putting them, it would be 0 0 followed by a whole bunch of ones. And again, 0 0 on the other side, followed by a whole bunch of ones, like that. So as you can see, whenever you have this type of scenario, and you can do this for 3, 17, ... all the way down to 19 and 1, each of these is going to give you 2. So since there's 19 of them, and each of them give 2, you give 19 times 2, which is 38 of these sequences. All right, so far, hopefully, this is not any bit confusing for you. Now we get into a scenario where you can place them in the middle somewhere. So for example, same story, zeros and ones. So I'm going to start with 1 0 and 19 ones. But now, if you look at, the position of where to put them, here, I just put them at the ends, right? Either here or here, assuming that's the end. So what I'll do is, since I'm not drawing out all 20, I'm just going to put ... So now what I'm going to do is put the 0 somewhere, either here or here or here, wherever. And we have to think, how many ways are there of doing that? Well, there's 20 for this particular scenario. Right? The 0 can go any of those places. Now you might say, well, doesn't that count these also? And the answer is yes, it does. And that's why at the very end we have to subtract this number, because we're going to end up overcounting. Now for 2 zeros, 18 ones. The zeros can go here, or the zeros can go here. The zeros can go here, and so on, right? Because notice the question says that all the zeros or all the ones. The zeros and the ones don't all have to be consecutive, because if that was the case, this would be the only ones. They say 0 or the ones. So that's why this has now 19. If there's 3 zeros and 17 ones, the 3 zeros can go either at the very beginning, or you can shift them over, and you can shift them over, so on. And there's 17 ways of doing that, and so on down, right? All the way down to the very last one, which is 19 zeros and 1 1. And there's only 2 ways of shifting those 19 zeros so that they remain consecutive. So our task now is to add these up. And that is basically the sum from 2 to 20. So I'll just use the sum of 1 to 20 and then just subtract 1. And that looks like 10 times 21, 210 minus 1, so 209. All right. So we have just one more way, one more scenario, and that is pretty much identical in terms of the math. The only difference is we're flipping the ones and the zeros. Now it's the 19 zeros and 1 1, 18 and 2, 17 and 3, and so on down, all the way till you get to 19 ones and 1 0. So it's the same story. This time we're concentrating on the ones. There's 20 ways of placing the ones. There's 19 ways of placing 2 ones together. There's 18 ways of putting 3 ones together, and all the way down to 2. So again, this is going to be a 209. So at the very end, be careful now. We've got to add, obviously, the 209 plus the 209 plus this 2 at the very beginning, and then subtract from this 38, because remember, this is counted in here already. So a better way of explaining that is that if you were to take all of these guys and all of these guys and look at them, you'll notice that some of them will have been overcounted. By how much? By 38. Because, for example, this one, which is 1, 0, and 19 ones, is one of these guys, 1, 0, and 19 ones. But it's also these guys, one of these guys, 1, 0, and 19 ones. So that's why the double count has to be subtracted. So if you do this, 209 plus 209 plus 2 minus 38, it's 382. And therefore, the answer is E. Two parabolas have equations y is equal to x squared plus ax plus b, and y is equal to x squared plus cx plus d, where a, b, c, and d are integers, not necessarily different, each chosen independently by rolling a fair six-sided die. What is the probability that the parabolas have at least one point in common? So we have x squared plus ax plus b, and we have x squared plus cx plus d. Now these two parabolas, they want them to have at least one point in common, so they want them to intersect. So set them equal to each other, and when you do, you'll notice that the x squareds cancel, so that makes things simpler for us, and all you're left with is really two lines. So we have two lines and we want them to intersect. Well, it's not a problem. If two lines intersect, usually it involves 1 point. So that's exactly what they want. But they want you to figure out the probability of them intersecting, not necessarily the point of intersection. So what we have to do is look at what is the probability that they don't intersect. And then once we get that probability, we can subtract it from 1. And that will give me the probability that they do intersect. So let's talk about when they don't intersect. So this guy right here. They will not intersect if they are parallel. If those two lines are parallel, there will be no intersection points. So how can they be parallel? They will be parallel if they have the same slope. And that means that A is the slope of this line and C is the slope of that line. If they have the same slope, that means A must equal C. So that's the first condition for those lines to be parallel. The other condition is that B cannot be equal to D. Why is that? Because if B was equal to D and A is equal to C, it'd be the same lines. They'd be on top of each other. And two lines that are on top of each other obviously intersect infinite number of times. So we want A to be equal to C. That makes it parallel. But we do not want B to equal D because we don't want the lines to be identical. So these are the conditions that we want. Well, for A to be equal to C, remember there's 6 numbers on that die that they are using. It's a fair die. So the probability that you roll a number A, let's say it's 1, the probability that C is the same is it's got to be also 1. So if you roll a 1, the next number has a 1 in 6 chance of being the same. So the probability of A equal to C is 1 over 6. Now the probability that B does not equal C. Well, the probability that B does equal C is 1 over 6 by the same logic I did up here. So the probability that B does not equal C is 1 minus 1/6, which is 5 over 6. So the probability of both of these things happening are 1/6 times 5 over 6, which is 5 over 36. So that is the probability that these lines do not intersect, 5 over 36. But we want that they do intersect, so you have to do 1 minus p. And that's going to be 1 minus 5 over 36, and that is 31 over 36. So number 13, the answer is D. Bernardo and Sylvia played the following game. An integer between 0 and 999 is chosen, inclusive, is selected and given to Bernardo. Whenever Bernardo receives a number, he doubles it and passes the result to Sylvia. Whenever Sylvia receives a number, she adds 50 to it and passes the result to Bernardo. The winner is the last person who produces a number less than 1,000. Let n be the smallest initial number that results in a win for Bernardo. What is the sum of the digits of n? We have Bernardo and Sylvia. So initially, you take some number from 0 to 999, and then you give it to Bernardo. He then doubles it. And this is the number he produces. So it's very important to allocate these numbers properly, because if you allocate it to Sylvia, then the question will get all messed up. Then, this is the number he produces. He then passes it to Sylvia. She adds 50 to it, so 2x plus 50. And then, this is the number, therefore, that she produces. That's why it's allocated to Sylvia. Then she passes it back to Bernardo. Bernardo always doubles the number, so his number then becomes 4x plus 100. He now has produced that number. He passes it to Sylvia. She adds 50 to it. And this process continues. Bernardo gets it and doubles it, so it'd be 8x plus 300. And then gives it to Sylvia, and she adds 50 to make it 350. Then she gives it back to Bernardo. He doubles it. And then he passes it to Sylvia. She adds 50 to it. And then, again, she passes it over to Bernardo, and he doubles it. Now, at this point, Bernardo is clearly over 1,000, right? So we want Bernardo to have a number less than 1,000. That's the only way he can win. So if he gets a number less than 1,000, that means when he passes the number to Sylvia, her number is greater than 1,000. Okay? So we basically have to concentrate on this guy right here. That has to be greater than 1,000 in order for Sylvia to lose and Bernardo to win. So if 16x plus 750 is greater than 1,000, that means 16x is greater than 250, and x is greater than 250 divided by 16, probably a little over 15 point something, 15.6. So that means x has to be greater than 15.6. The smallest number, therefore, is 16. And you can verify this. You say, well, okay, when x is 16, what happens? If x was 16, this number is 956. And this number, you've added just 50 to it, so it's 1,006. So as you can see, with 16, Bernardo wins, and Sylvia loses because her number is above 1,000. Bernardo wins because his number is less than 1,000. So 16 is the smallest number, smallest initial number, such that Bernardo wins. And they want you to find the sum of the digits of that number. Well, the sum of the digits of 16 are 1 plus 6, which is 7. So number 14, the answer is 7. Jesse cuts a circular piece of paper of radius 12 along two radii to form two sectors, the smaller having a central angle of 120 degrees. He makes two circular cones using each sector to form a lateral surface of a cone. What is the ratio of the volume of the smaller cone to that of the larger cone? So first he has a circle, and then he cuts it in a way so that one segment is approximately 120 degrees. And then he takes those two segments and folds them up and creates two cones. So the first cone, of course, will be a bit smaller than the other. So we have, let's say, one cone that kind of looks like this, right? Like this. And then you have another cone that's a little bit wider, something like this. And we'll just draw in the circular tops. So something like that, right? So our task is to figure out the volume of this little guy and then the bigger guy. Okay, so here we go. First thing I'm going to do is draw a center to that top circular area and then a line to the bottom, and the same thing on the other one. Now, this was 120, and therefore the other one, it's got to be 240. The angle. Now, the radius is 12, this is 12, and this is 12. So that means from here to here is 12. And so is from here to here on the other cone. Now the heights are going to be different. We'll call this one H, small h, and this one big H. It doesn't really matter. And then this we'll call it small r, and this we'll call big R. So before I start calculating r's and h's, first let's figure out what is it that they want us to figure out. They want you to figure out the ratio of the volume of the small cone, and the volume of a cone is 1/3 pi r squared times height over the volume of the big cone, which would be essentially the same thing, but with big R and big H. And when you do this, the 1/3 and the pi's cancel, so all you're left with is the R's and the H's. So as you can see, obviously I have to figure out the numerical values of those. So this is the part of the question that will allow us to figure out R and H. First, we have to figure out that segment of the circumference, because that will represent all the way around here. That segment of the circumference is 120 over 360 times the original circumference of that big circle. And that is pi 2r. And that's 1/3 times pi times 2, and r is 12. So that's what? 36 divided by 3, so 12 pi. 12 pi represents that segment right there. Oh, sorry, it's not 12 pi, it's 8 pi. Sorry. 8 pi, it's 24 divided by 3, right? So 8 pi represents the length from there to there. But that length basically is all the way around that. So that means the circumference of that circle is 8 pi. Now the circumference is equal to pi times 2r, and that's 8 pi. So solving, we get r is equal to 4. So this r is equal to 4. All right? And we can easily use Pythagoras to figure out this h. So that's going to be 8 squared plus 4 squared, which is 16, is equal to 12 squared, which is 144. 8 squared, therefore, is 128. And therefore, h is the square root of 128. And that's going to be 8 root 2. And now we do the exact same thing over here. This time we're looking at this segment of the circumference. And that segment of the circumference, I think I can squeeze it over here, is 240 over 360 times pi 2r, and r of course is 12. So this is 2/3 times 24 pi, and that's 48 divided by 3, which is 16 pi. So 16 pi is how we're going to figure out this whole circumference, that being 16 pi. But the circumference, as before, is pi 2r, and that means solving for r, we get r this time equal to 8. So this is equal to 8. So that means 8 squared plus h squared is equal to 144. 8 squared is 144 minus 64, which is 80. So h is root 80, and root 80 is 4 root 5. So there we go. We've got all the numbers. We've got small r, big R, small h, and big H. So all we have to do is plug it into there, and we should get our ratio. So let's see here. That's going to be 16 times 8 root 2. And on the bottom, it's going to be 64 times 4 root 5. And that's going to be, let's see here, 16 over 16, 1 over 4, and then 8 over 4 is 2. So it's 2 over 4, so 1/2. So it's root 2 over 2 root 5. And then rationalize the denominator top and bottom by root 5. And you get root 10 over 2 times 5, which is 10. So root 10 over 10. And therefore, number 17, the answer is C. Amy, Beth, and Joe listen to 4 different songs and discuss which ones they like. No song is liked by all 3. Furthermore, for each of the 3 pairs of the girls, there is at least one song liked by 2 girls, but disliked by the 3rd. How many different ways is this possible? So let's talk about this first before we dive right into the solution. There's 3 girls. There's Amy, there's Beth, and there's Joe. Now, there's 4 songs. I'll call them S1, S2, S3, and S4. Now, we have to make a scenario that matches the criteria in the question. No song is liked by all 3. Okay? So, song 1, let's say, is liked by A and Joe. So that means it's disliked by B. And for dislike, I'll put a red. Similarly, we can just put, S2s and S3s and like that everywhere. So anyway you'd like, say S2 is here, S3 is liked by those 2, and S4 say is liked by those 2. And then of course we have to put in the fact that it was disliked by the other girl. So this is one scenario that is fitting the question, right? That they listen to 4 songs and no song is liked by all 3. So as you can see, no song has 3 colored in blue. And now we have to talk about the second part of the question, which is the pairs of the girls. So what pairs are there? There's AB, there's AJ, and then there's B and Joe, right? Those 3 pairs, there's at least one song liked by those 2 girls, but disliked by the 3rd. Okay, so let's talk about that. For AB, which is the song that both of them like? Well, A and B both like S3. S3 was the one that both of them liked. And was it disliked by Joe? Yes, it was. So as you can see, that matches. It's right here. A and Joe, which song was liked by both of them? S4. Well, S1 also. Well, it doesn't really matter. I'm just trying to explain this. So S1 was liked by both, and S1 was not liked by the other party, which in that case was B. And then B and Joe, which ones do they like? The way I wrote it, S2 is the one they like. And A disliked S2. So the point I'm trying to make with this example, that's one possible way of doing it. They're saying how many different ways are possible? All right, well, that's going to be a little bit more complicated than just one scenario. So here is the explanation. Each song is liked by 2 of the girls, correct? Then one of the 3 pairs of girls likes one of the 6 possible pairs of songs. So for example, A and Joe like S1 and S4. One of the remaining pairs likes one of the remaining 2 songs. So that, let's say B and Joe, they like S2. And the last pair likes the last song. So the last pair is A and B, and they like S3. So what they're saying is that all can happen in the following ways. 3 times 6 times 2. And I believe how they got that is 3 pairs of girls, 6 possible pairs of songs, and you've got, of course, 2 songs. So, for example, let's explain this. You've got each song is liked by 2 of the girls, right? As you can clearly see, that's the case right up here in my little example. And then each of the 3 pairs of girls likes one of the 6 possible pairs of songs. So our pairs are AB, AJ, and BJ. And the 6 possible pairs of songs are S1, S2, S1, S3, S1, S4, S2, S3, S2, S4, and finally S3, S4. So in our case, we have A and J, let's say, likes one of the 6 possible pairs of songs, and our pair for A and J is S1 and S4. And one of the remaining pairs of girls, so for example AB, likes one of the other 2 songs. So AB likes S2, S3, just S3. And then there's one song left, and that obviously belongs to the other pair, which is BJ. And BJ likes, obviously, the one song that's remaining, which is S2. So the 3 that they have here comes from here, 3 possible choices. The 6 comes from this, and the 2 comes from the fact that once this is selected, you've got 2 choices remaining for here. It could be either S3 or S2 in my example. And then the last one for BJ is just going to be the very last song by default. So that's how they get 36. Okay, I hope that was explained well. Now let's look at the other case. 3 songs are each liked by a different pair of girls, and the 4th song is liked by at most 1 girl. There are 4 factorial, which is 24 ways to assign these songs to these 4 categories, and the last song can be liked by Amy, Beth, Joe, or no one. This can occur in 24 times 4, which is 96 ways. So one song is liked by AB, one song is liked by BJ, and one song is also liked by AJ. So for the first pair of girls, there's 4 possible songs that they could like. S1, S2, S3, or S4. So there's 4 possible. Now the next group, BJ, they can like any of the remaining 3. Either, if AB liked S1, BJ can write like S2, S3, or S4. So there's 3 possible choices. For AJ, they've got only 2 possible choices. Now at that point, there's 1 song left. And that one remaining song can be liked by an individual girl, either A, B, or J, or by nobody. So there's 4 possible ways of that last song being allocated, so that's why you put a 4 there. And this is the total number of cases in the second scenario, and that totals 96. So you have to add the 36 with the 96, and when you do, you get 132 total number of possibilities. And therefore, this question number 24, the answer is B. Square PQRS lies in the first quadrant. Points 3, 5, 7, and 13 lie on lines SP, RQ, PQ, and SR respectively. What is the sum of the coordinates of the center of the square PQRS? So here is PQRS, and the lines SP will meet at 3, 0. RQ, which is this one, meet at B, which is 5. And then PQ extends to C, and that is 7. And then finally SR extends all the way to D, and that's 13. So that's the initial setup of the question. Now, take a look at 2 triangles, and that first triangle is AGB, and the second triangle is CHD. You will see that those 2 triangles are similar. AGB is this small guy right here, and CHD is the big one right there. They are similar because they share the same angles, and you will notice that because this is a right angle right here, and this is a right angle also. And then this angle theta and this angle is theta because those lines are all parallel. So those are similar triangles. So that means the ratio of the sides will be the same. So for example, AB over CD, initially you can just get that without even ratios, just by the distance. It's 3 to 5, so that's 2. And then CD is from 7 to 13, which is 6. So that ratio is 1 over 3. All right? And then similarly, we can do the same kind of comparison with the other sides. For example, GB over HD, like that, GB over HD will be equivalent to AB over CD. But AB over CD is 1 over 3. So that means GB over HD is 1 over 3. But note something very interesting, that GB, because it is here, this is GB, it's the identical to that, PQ, which is a side. And PQ is the same as RQ, it's the side of the square, and RQ is the same as HC. So in a roundabout way, we conclude that GB is equal to HC. So that means that this can really be written as HC over HD is equal to 1 over 3. So that means this over that is 1 over 3. So essentially what that means is that any triangle that's similar, this side will be, compared to that, have a ratio of 1 to 3. So in a very similar way, this side AG will be 1 over 3 if you compared it to GB. All right, so that's a very important finding right here. So now what we do is we turn our attention to this triangle in here, EMF, this one, EMF. In that triangle, you'll notice M is the midpoint. So this midpoint, if we can find its coordinates, we can add them up and we're done with the question. Now, in that triangle, you'll notice that there's a couple of relationships. That MKF, that triangle, MKF, where K is going to be the point that I drop to meet the side perpendicularly, like this, where this is a right angle. And this is my K. MKF, so this triangle MKF is similar to AGB. Now at first that may not seem obvious, but I'll explain why. This is a right angle, and this, let's say, is theta. Therefore this angle in here, in that smaller triangle AGB, is also theta, right? Because these lines are parallel. Now that means both of these have a right angle and theta, and therefore the third angle is the same. It's 90 minus theta. And that's why those two triangles are similar. In addition, the other part of that, which is EKM, interestingly, is also similar to AGB. So EKM is this guy right here. As you can see, that also has the same angles. It has a 90. This angle in here is going to be 90 minus theta, and this angle in here will be theta. Compare it to the other triangle. So we've got two more similar triangle relationships. So here we go. So what I will do now is start labeling these. We have to give these values. So I know that the ratio of the sides of any triangle that's similar to AGB will be 1 over 3. So since MKF is similar to AGB, This, compared to that, will be a ratio of 1 to 3. So mk I will label 3x, and therefore kf, this whole guy, will be 9x. So I'll put that there. And in a very similar way, since this triangle is also similar, its sides also have to have a ratio of 1 to 3. So since this is 3, ek, therefore, from here to here, has to be x, since it's got to be 1 to 3, where the smaller is obviously 1 and the larger is 3. So we are almost done with the question. Now we know the distance all the way from E to F, according to my labeling, is x plus 9x, which is 10x. But E all the way to F, we actually know the distance. E is 4, F is the midpoint from C to D, so that's going to be 10. So that means from E to F is 6. And therefore x is 6 divided by 10, which is 0.6. And therefore now we can calculate the coordinates for M. The coordinates for M, well, it's from the origin all the way until K. Well, the origin to E is 4, and then you just have to add an x, so it would be 4.6 for the x coordinate. And the y coordinate is just 3x, top to bottom. So that's going to be 3 times 0.6, which is 1.8. And there we go. We just got the coordinates of the midpoint of that square. Now we just have to add them. So it'll be 4.6 plus 1.8. And that is 6.4. So number 17, the answer is C. Let a1, a2, ... until a10 be a list of the first 10 positive integers such that for each I between 2 and 10 inclusive, either ai plus 1 or ai minus 1, or both appear somewhere before ai in the list. How many such lists are there? Well, they're saying that this is the first 10 positive integers. So that means that must be these numbers in some order, not necessarily in this order, but these 10 numbers have to be A1 through A10 in some order. All lists have to have these 10 numbers, the first 10 positive integers. Now we have to figure out a way of arranging this. If you analyze this question carefully, if you understand it, you will basically see that whenever you take a number, for example, let's say that number is 3, and that is our AI. Then they're saying AI plus 1 or AI minus 1, which in this case would be either 4 or 2, both, either or both, appear somewhere before the 3. So that means in this list, the 2 would appear before the 3, or the 4 would appear before the 3, or both appear before the 3, right? Either this one or both. So we just have to figure out all the arrangements. So let's start with the first number being a 1. If the first number is a 1, then that means all the other numbers have to be between 2 and 10. And really, there's only one way of doing that, which is making them the same way that you have up here. So in brackets, I'll just put how many possible ways of doing that. There's only one way of doing that. If the first number is a 2, then I've got to make sure that somewhere in the next 9 numbers, I've got to put a 1. Because if this is 2, then obviously that has to appear before the 1. And the 1 can go anywhere. So of the 9 possible places, I have to choose 1. So 9 choose 1 is the way of figuring that out. And that is equal to 9. And then if the first number is 3, in the next 9 numbers, I've got to place the 1 and the 2. And the 1 and the 2, out of the 9 possibilities, I've got to choose 2 places for the 1 and 2 for those numbers. And 9 choose 2 is equal to 36. If the first number is 4, in a very similar way, in the remaining 9 numbers, I've got to place the 1, 2, and 3. And from 9, therefore, I've got to choose 3 slots for those 3 numbers. And that's 84. And then you just keep doing this. So when it's all said and done, the total would basically be this 1 up here, plus 9 choose 1, plus 9 choose 2, all the way up until the very last one, which is 9 choose 9. And that is 1 plus 9 plus 36 plus 84 plus 126 plus 126 plus 84 plus 36 plus 9 and plus 1. So the good news about these is that they kind of rise and fall in the same way. It saves a little bit of time. And when you add it all up, it's 512. So 512 is the answer to number 22, and that makes it choice B. A unit cube has vertices P1, P2, P3, P4, P1 reflection, P2 reflection, P3 reflection, P4 reflection. Vertices P2, P3, P4 are adjacent to P1. And for I between 1 and 4 inclusive, vertices Pi and Pi reflection are opposite to each other. A regular octahedron has one vertex in each of the segments, P1, P2, P1, P3, and so on. What is the octahedron's side length? To calculate the side length of the octahedron, we can use this very helpful diagram right here. And this diagram just puts one aspect of the octahedron. It doesn't put the entire shape. And what we're really looking at is a few of the sides. And what we can do is look at the vertices, and we can call the distance from here to here x. And if that is the case, then this point is labeled appropriately x, 0, 0. And then the distance from here to here is also going to be x. And therefore, we can easily figure out that distance using Pythagoras, because this is, of course, a right angle. So if I call this d, x squared plus x squared is equal to d squared. So 2x squared is equal to d squared. So that means d is equal to root 2x. So immediately we got the value for that. And that represents the side of the octahedron. That's the side length. So we know it's root 2x, but obviously we have to find a numerical value. Now if you start labeling the other points, you'll notice that the distance from here to here is also x. And therefore this coordinate right here, it's going across 1, that's why this is 1, and it goes this way, not all the way, so it's going 1 minus x, that's why this is 1 minus x, and then of course it went up 1, and that's why this is 1. So this is appropriately labeled 1, 1 minus x, 1. So now what we can do is use this point, and in particular the distance formula, and that will give us this distance from here to here, and that distance is also d. And since this d and this d are equal, right, because it's a regular octahedron, what that means is that all the sides are the same. We can just equate them. So using the distance formula with this point and this point, we get x minus 1 squared plus 0 minus 1 minus x squared, like that. And then, of course, 0 minus 1 squared. And then all under the square root sign. And that is equivalent to this d, which we had just figured out was root 2x. All right. So Let's immediately square both sides and get rid of the radical. If I do, this is going to become 2x squared like that. And then underneath the radical, expand it, x squared minus 2x plus 1. And then this is going to be, this is also x minus 1, so it becomes x squared minus 2x plus 1, and this is just plus 1. So now it looks like the x squareds cancel, so this becomes very easy to work with. 4x plus 3. All right, well that means that 3 is equal to 4x, and therefore x is equal to 3 over 4. So our d, which was root 2x, is really root 2 times 3 over 4. Or you can just write it as 3 root 2 over 4. And that is the side length of the octahedron. And the answer choices aren't shown here, but just for your sake, that was answer choice A. Here is that original question. The reason I didn't use this one diagram is because this diagram is a little misleading, in my opinion. But regardless, 3 root 2 over 4 is the correct answer for number 19. A trapezoid has side lengths 3, 5, 7, and 11. The sum of all the possible areas of the trapezoid can be written in the form of r1 square root n1 plus r2 square root n2 plus r3, where r1, r2, and r3 are rational numbers and n1 and n2 are positive integers not divisible by the square of a prime. What is the greatest integer less than or equal to r1 plus r2 plus r3 plus n1 plus n2? The question is talking about a trapezoid, so as always, we can draw a trapezoid and discuss what can be a possible scenario. And we will also make a table and try to see what those scenarios are. So I will label this A, B, and here's side 1 and side 2. So we'll put that in the table, A, B, side 1, side 2, like that. And then of course we have to figure out areas, and that should be pretty good for now. Now B, we know most likely is going to be the 11 of these numbers given, because just the nature of the diagram tells us that it's most likely 11. Now A therefore can be any of the other. It can be either 3, 5, or 7. Okay? If that is the case, then therefore S1, S2 over here are 5 and 7. In this scenario, it's 3 and 7, and here it's 3 and 5. So for each of these, we have to figure out the area. And the technique to do this is first, let's draw a distance that is the length of A, but on the other side. So from here to here approximately. And the reason I'm doing that is because if I do that and join, it becomes a parallelogram, where this is A, the length of that is A. And therefore this distance is B minus A. So I'll put B minus A here. And we can fill that in pretty quickly. This is going to be 8, this is going to be 6, and this will be 4. So now we can also deduce that since this is a parallelogram and this is S2, that will also be S2 in terms of its length. So there you go, S2 right there. So what we have is a triangle and a parallelogram, and we can go one step further and just cut that parallelogram in half. And when we do, once we get the area of that, we can double it to get the area of the parallelogram. Okay, so that's the strategy. And I really don't want to make things more confusing, but I will label this A, B, C, D, and this point I will call E, right there. Okay, now we can proceed with the question. And what we are going to use in this question is something called Heron's formula. And some of you are familiar with it. It's a way to calculate the area of a triangle if you know the three sides. And the formula is S minus A times S minus B times S minus C times s, all under the square root sign. And s is basically half of the perimeter of the triangle. Well, let's proceed. So for the first scenario right here, we will first calculate the area of ADE, that triangle. And using herons, it's going to be the perimeter divided by 2, which is going to be S1 plus S2 plus B minus A, so these three. If you add those up, you get 20. Divided by 2 is 10. And then it's going to be 10 minus one side, so it'll be 2 times 10 minus the other side, so that'll be 5. And then 10 minus 7, which is 3, all under the square root sign. And that is 300, or 10 root 3. So very quickly, we got the area of ADE. Now, if you look at this triangle, if you actually write the values here for B minus A as 8 and A as 3, you will notice that triangle AEC is equivalent to 3/8 the triangle ADE. And that's because they share the same height. And that's why you can have that conclusion. So that means that the area of ADE is what I will place right here, and then multiply it by 3/8. And when you do, you get 30/8 root 3. Now, the good news is that ABC is the same as triangle AEC, so ABC is also going to have the same 30/8 root 3. And now to get the area of the trapezoid, we just have to add those three. So you take this one, you take this one, and you take that one. And when you add those three, you will get 35/2 root 3. So that's what I put right here, 35/2 root 3. Okay, so I hope that made sense. Now we do the exact same thing with the next scenario. Again, now we do ADE, herons in this case. We would add these, so that's going to be 16, therefore the semi-perimeter will be 8. And then we have to take 8 minus 6, which is 2, 8 minus 3, which is 5, and 8 minus 7, which is 1. And therefore 8 times 2 times 5 is root 80, which is 4 root 5. And very similar to before, triangle AEC in this scenario, let's change the numbers here. It's not 8 and 3 anymore. It's this. A in this case is 5, and therefore B minus A in this case would be 6. So AEC is really 5/6 of triangle ADE. So that gives me 5 times 4 root 5, which is 20 root 5/6. And very similarly as before, ABC is going to equal the same thing. And now the area of the trapezoid, you just have to add them all up. This one, and this one. And when you do, you get 32/3 root 5. So that goes here, 32/3 root 5. And then the final one, same kind of story, ADE, using herons. You add these up, you get 12. 12 divided by 2, the semi-perimeter is 6. So you have 6 times 6 minus 4, 2, 6 minus 3, 3, 6 minus 5, 1. And that is actually just 6. No more radicals anymore. And then triangle AEC is going to be, this time, these are different numbers. This is going to be, let's see, A in this question, this scenario I should say is 7, and then this is 4 now. So AEC at this point is 7/4 of triangle ADE. So that means it's 7/4 times 6, which is just 42/4. And ABC, that triangle, is the exact same, 42/4, or 21/2. And then now the trapezoid, you just have to add up those 3 that I just calculated, and when you do, you get a sum of just 27. There we go. So now we have to add up these 3. It's 35 over 2 root 3 plus 32 over 3 root 5 plus 27. Now we have to compare it to what they have in the question. This sum that I just discovered is this right here. It is my R1 times the square root of N1 plus R2 times the square root of N2 plus R3. As you can see, it matches very nicely. So they want you to just add up those numbers. Okay, what that basically means is 35 over 2, which is my R1, plus 3, which is my N1, plus 32 over 3, which is my R2, plus 5, which is my N2, plus 27, which is my R3. And when you add these up, you get approximately a little over 63.2 approximately. So they're saying, what is the greatest integer less than or equal to? Well, the greatest integer less than or equal to that would be 63. And therefore, number 20, the answer is D.